Hello, everybody. I'm very sorry I'm streaming late because, I forgot time. So busy chatting in Telegram. So, yeah. So let's continue on. Let's pick up from our what we did yesterday. So what I'm going to show you is what I've been thinking since yesterday. What we're going to do. Um, yeah. As you can see from here, hold on a second. Oh, how can I forgot? Yeah, yesterday we have done a monitoring client, what we call as a Symon-Agent. This monitoring client is using a key value configuration or context where information that need of information or data that need to be done by the agent is all inside this context, and whatever the result from this agent done, whatever the result, the response, and all the data is will be put back in the context. So let's visit what is actually inside the context. From our last programming task here, when this execute function is called, it will read information from the context, and then we extract some information, how many call we're going to make from the monitoring task, and then for each number of calls, we're going to extract some more. For the first call, what is the HTTP request URL, what's the HTTP request method, and then after that we do the call. Yeah, we make sure that all the value is all the mandatory value is there, and then we construct the request, and then from the request that we construct, we put some header inside the request, we put some header body, and then we create the client. And then from the client we execute, and then we timed the execution, sorry. And then from there we put all information that we get from the HTTP request. We get as HTTP response, and we extract all information that we can from the response. For example, we get the duration, how long in millisecond we do the HTTP call, and then the response code we put inside. See, response to the status code we put inside the HTTP response code, and so on and so forth. So from the context we get information of what server we need to call, how we're going to call them, and then once we get the response, all information about the response we put back also inside the context. So the context eventually, up until now, will have these informations. Okay, the context key HTTP monitor count should have how many calls that we need to do, and for each of the calls we have, if we put something like count is equals to, like this, if we put some, for example, we put count is equals to 2, means that the 0, I mean, if we put 2 means in Golang we put index is always start from 0, so if we put 2 means there is a 0 and 1. So the first request, the 0 one, we have a URL to call, and then we have a method to on how to call the URL, and then what header we need to put. Here, for example, we have a content type header, and then we can put body inside the content type. So now the challenge is that from the first call to the second call, sometimes the response of the first call will be used inside the call, the request on the second call. For example, when we do, like yesterday when I explained about this, when we try to test the dashboard, a server, a web application, for example, we want to make sure that the dashboard loads fine. So first, in order to access the dashboard, we need to do login authentication first, meaning that we need to access the login URL, and then from that response, from the first login URL, the response, we're going to use some of the response in our second request. For example, this. You can see for the first request, we're going to call, for example, abc.com/login. And we're going to do it using a post call. And then we put the content type. Login, we have a username and then the password. For example, something like this. Okay, content type will be application/JSON, and the body, of course, is going to be a JSON. So, and then what we're going to do, we're going to execute this. We expect after the response is received, the HTTP response from the first request, the information inside the request will be used inside the authentication mechanisms on the dashboard. So second, we're going to call dashboard using get, but it will put authentication header inside this request with a value of bearer, a string, and then followed by some value coming from the body of the first request. You can see that 0 HTTP response.body. So we expect that once this request is executed, this key will be there inside the context. And if we have this, then it should be a JSON. And then within the JSON, we will have, we will parse through the path inside the JSON where it should be have data and then access, and whatever the value will be concatenated in the bearer, something like that. So you can see this is something new because I am thinking this since yesterday, since our last stream. We need to have this kind of capabilities. So inside all of this key is not only just string, it is more than just string, it's actually an expression. It is an expression. So an expression of what? An expression of something that can be evaluated, and then we can defer a value from this expression. You can see that this key, HTTP monitor count, is 2. 2 is what? 2 is an integer literal. So we know that this key will return an integer which is the value is 2. So this is actually an expression. What we call in programming is expression of a constant. This is also an expression which is a string literal. That means that if we put this key with this value, so that this key will contain a value of a string, which is the literal is this string. So we're going to put some expression. As you can see, everything that will start with a double quote and end with double quote, it will be a string literal. Content type also a string literal. This is also a string literal. How about this? This is an expression because everything is an expression. So this expression is involving a concatenation operation, which is the first part is a string, the second part will be a function. So we are kind of creating our own language here. So we can do a plus, we can do a minus, we can do something like, how about the HTTP monitor that we're going to do is 2 plus 4. So we're going to have 6 steps, something like that. This is valid. Or maybe something like this. Parse integer from 2, 3. This is also valid because this is actually an expression. This expression, this time, is calling a function which is require an argument of string. The return of parse integer will be integer. And the value will be put inside this key. So our context will be enriched with what we call it a DSL. DSL, domain-specific language. Language which is specific for our application, which is Symon. So how can we create our own language? Okay, Um, if we just use our own logic to do a processing, if we do our own logic for a processing with what we know with string substring, we cut a string from the left, cut string from the right, and then looking for some pattern, maybe using a regular expression, will be a very, very hard job for us. We need to be able to see that this whole string, we need to identify which one is the string literal, which one is the operator, which one is the function, and everything. So this will be a very difficult task. First, we need to look for character quote, and then look for the second quote to make up for the string literal, and then we need to force some operator, and then we need to put some of the a pattern of a function, and everything. Then this is going to be crazy. Instead, we're going to create our own DSL, using a very, very, very known library or tools that we can use to make our own interpreter, something like that. Parser is ANTLR4. ANTLR4 is, I think, let's open the website of ANTLR4. Simply go to ANTLR. Okay, ANTLR is a abbreviation of another tool for language recognition. So this is actually a tool for you to create, for you to be able to create your own language. So this is most of the time how people actually create their own language, how they create their own parser. It's very easy. Actually, it's very easy. People just getting crazy when they hear that, let's create our own language, and then they getting crazy. Oh, it's so difficult. Why you are creating your own DSL? DSL is not something simple. It's very complicated, difficult to do, etc. But yes, it's very, very complicated, very, very difficult. Lots of hardcore logic we need to implement when we want to create our own compiler or interpreter. But not if we do something like ANTLR. In ANTLR, what is actually ANTLR? ANTLR is a library to parse a grammar definition, because language has a grammar. It has a predicate, it has subject, it has an object. So it's pretty much like a human sentence analyzer. It will identify which word is actually talking about the subject, which one is talking about the object, which one is talking about the predicate, the nouns and everything. So our language also have a pattern, just like a human natural language. We have a pattern. For example, you can see that when you have a series of alphabet and then followed with an open brace, a quote, and a closing brace, then we know that this is a function. Okay, a pattern. If we see that there is a string started with a quote and then ended with a quote, then this is actually a string literal. So there is actually pattern. A post pattern, not post pattern, a string literal. This is actually a pattern. This is actually another pattern. Our language will be able to process two literal with operation to another literal, another function, for example. So we can put this as minus, divide function, or whatever function we can do wildly, as long as there is a definitive pattern of a language. When you go to Golang programming language, C, JavaScript, any language, they have a pattern. So this pattern should be we should be able to look into this pattern and identify what is the operation that we want to do with this pattern. But the tokenization of each of these information should not be done by us. If we're going to do the tokenization of string, the substring of everything inside our language, then we're not going to finish this tutorial. You will not finish me done this DSL within another 1 year maybe. So we have a tools which is what we call ANTLR, and this ANTLR will do all the string tokenization, sequencing, and then try to look the pattern that this is a function, that this is a string literal, then this is a constant of a float, something like that. So this is let ANTLR do the heavy lifting for us, and then we only need to know what kind of pattern it is, and we need to know we only do what we need to do according to some pattern. So without delaying further, let's work with ANTLR. So we need to have our own language. Okay, in ANTLR, the grammar language, I will show you along the way, so you don't have to be worried. Okay. I will show you how ANTLR do this tokenization and also figure out what is the pattern. In ANTLR, they have a grammar definition put inside a G4 file. Let's create a G4 file. New, a file. We call Symon-Lang. Symon-Lang.g4. Okay. You can immediately that you have a logo of ANTLR there, because Golang, the ID, my ID here, immediately able to identify a Golang, an ANTLR file. It's also integrated into the IDE, and let's go. So let's put a grammar. The grammar name should be equals to the name of the file. Must, in fact. So Symon-Lang, and then we should define our own a fragment of our strings. So when you see a string, there are chunk of string that can be identified by ANTLR that this is actually part of some string pattern. So for example, let's define our own. Oh yeah, by the way, in the world of parsing, there are two types of parsing steps. The first one is what we call lexer steps. Lexer will identify sequence of strings. Parser will identify sequence of pattern. So the sequence of string, we put it in the lexer. So let's put a lexer. Lexer here. So we put a lexer. We put a fragment, for example. A fragment, an A fragment, is consisting of an A lowercase or an A uppercase. Sorry, this is not how we should write it. Something like that. So when we call an A, it could be a lowercase a or could be an uppercase A. Okay? And then fragment B. Something like that. Oh, sorry, B or a B uppercase. Then we need to do this till Z. Let's not torture you with what I did here. So let's copy from my other project. Let's copy from my other project, because otherwise you are going to watch me doing this nonsense here, like that. So we have an A, B, C, D up to Z. So we know that when we say an A follow a B and follow a C, it could be an A, B, C in all lowercase or uppercase, something like that. So this is our fragment. And then from our language construct, we need an operator. That could be a plus, could be a minus, division, multiplication, mod, something like that. So let's put something like this. So why there is a fragment here while there is no fragment here? A fragment means that it's an atomic sequence of string that cannot be parsed, but it is valuable for the following lecture sentence. So this lecture sentence cannot be used inside the parsing mechanisms, but it can be sequenced together within another lecture, and the lecture without fragment can be used within the parser. Don't think about it too much. You will know about this when you go deep in, when you create your own language and you go deep into ANTLR. So just bear with me, just follow along. Okay. What else? I need to look into my notes. What I need to do? Yeah, nobody. I'm very sorry. I late by like 15 minutes from the stream, but let's make it out. I hope. Okay. What we're going to do next? Let's define some more fragment, because from our construct, the language construct, we could have a string literal. How we can make a string literal? A string literal. Let me peek into the code of my other project. Okay, a string. Double quote string. Okay, this. You can see? Okay, double quote string is a string where it will begin with a double quote, of course, and it will end with a double quote. It can contain any characters. This is symbolizes any characters. The dot is as any characters. This is the skip, because dot could be taken as a dot, or a dot as to signify any character. So it could be a dot, or it can contain another quote within the string, or it can be any escape characters. So this is our double quote string. Okay, and then we also have integer literal, something like this. Three is 4, 2. This is an integer literal. That means that the language need to be able to identify an integer. So what is an integer? Integer is actually a sequence of numbers, right? What is numbers? Okay, number is, hold on. Something like this. A decimal digit. What is a decimal digit? Yeah, decimal digit. Okay. Okay. So decimal digit is any character which is starting from 0, character 0 to character 9. So it can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then a decimal digits is a sequence of this, a sequence of decimal digit. So decimal digits is a sequence of decimal digit. So it can be 1, 2, 3, 0, 1, 2, 5, 0, 0, 0, whatever. Okay, but is this a decimal literal? Decimal literal should be started from none then 0. Okay, it should be started from none then 0, followed by a decimal digit. So decimal digit could be any digits, which is a sequence of digits. So it's either 0 alone, or this is an alternative pattern, that a decimal literal could be a 0 alone, or something started from 1 to 9 and then followed by a decimal digit. So decimal digit here means a question mark, means that it is optional. So it can be there, it can be, it is not there, it's no problem. So if we have just a single character 3, means it falls into this decimal literal, because it fulfills this 1 to 9, so there is a 3, but there is no following digits, because this is optional. Or a single 0, or could be 1000, 1000, so there is a 1, and then there is a decimal digit following it, which is the decimal digit is a sequence of decimal digit. So I hope this is not too confusing. What else? We need to have a true or false, which is a Boolean literal. Okay, Boolean literal is something like this. So we need to define our parsable fragment, something like that. So a true is a sequence of T followed by R followed by U followed by E. So T is, what is T? T is actually either a lower or an uppercase T. R is like that, could be a lowercase r or a capital R, and so on and so forth. So true could be a true with the first letter capital, or could be all in uppercase or all in lowercase, doesn't matter. So this is what we call is in case insensitive. Okay. I hope, yeah, if anybody want to have question, just ask away. I hope this is pretty clear. This is the grammar definition of using ANTLR. Okay, and then what we're going to do, we have a double quote string, we have the decimal literal, we have Boolean literal. So Boolean literal could be something, we could create something like this. Bool literal is, it could be a true or a false. Okay, and then we can put what we a real number, a literal. We have an integer. Do we have integer? Yeah, decimal literal, we call it, let's put it integer literal, string literal, and then we need a real literal. Okay, real literal should be expressed in base 10 decimal. We cannot put a hexadecimal in our floating point. Real is a floating point, right? So we can put, let me pick into my project. Where is it? Sorry. There you are. Like this. Ooh. something like that. So it's actually requiring a decimal literal. Last time we changed this into integer literal. We need a dot. I will show you how it's actually working later. Please bear with me. Okay, we need a dot. We need an exponent. Do we need decimal exponent? I don't know. So that is our real literal. Okay, let's create a parser. Now we have a constant. No, not like that. So how are we going to do this? Let's create a parser of string literal first. String literal, where are you? Okay, there you are. Okay, we put here the parser. Okay, string literal. Okay, this is actually when you see something like this, you should not be confused, because this is actually the same as like this. See? And then it ended with what is it called in English? Titik koma. I don't know what this is. So yeah, actually a real literal is this pattern or this pattern or this pattern. That's it. This is the end. So in order to make it easy to read, we just put it like this. Much easier to read. Okay, you can do this like, yeah, no problem. Something like that. Something like that. And that. Yeah. So it should be easy. Yeah. So our string literal will have a pattern of string literal, which is this is the string literal. Okay. Let's try this out. Okay, let's look into the structure. Okay, we have a string literal. Let's test this. So if we put something like that, wrong, it is not a literal. If we put something like that, no, wrong, it is not literal. So if we put something like still not a literal until we close it, then you can see. You can see that it is identify a string literal which is contain a string of A, S, so on and so forth. So the ANTLR able to identify what is actually a string literal. String literal. Is this string literal? Yeah, this is string literal. Okay. Then we put an integer literal, for example. An integer literal contains what? Int literal. Oh, yeah. That's it. Let's save. Test again. Integer literal. Test. Okay, if you put something like that, still red, don't like it. If I put something like this, don't like it. This is not an integer literal. And then let's put, wow, it say that, yeah, there is an integer literal here. If you put dot, it is not integer literal. So it must be something else. Right, so let's put again a real literal. Or let's put it a float, much easier. Float literal. Floating point literal is actually a real literal, right? So it should be a real literal. Save. And then let's try our float literal. Test. Is this valid? No, it's not a float literal. You put dot, no. You put something, then yeah, it's a floating point literal. So it's we can easily identify which one is actually a floating point, an integer, or is a string. Or can we identify another literal, what we call is as a Boolean literal? So we have a bool lit there. So we just put it Boolean literal. Boolean literal is actually a bool literal. Something like that. Let's save, and then let's try Boolean literal. Test. How if I put, no, it is not a Boolean literal. It's not a Boolean literal. Maybe a true. True is a true, but why is it not part of the Boolean literal? What's wrong? Maybe something like this. You just put it, it's a true or a false. Yeah, there you go. Why is not working with the Boolean literal? Sorry. That's strange. Because this is not fragment. So anyway, it is a single fragment, so I don't know what I do is actually making sense or not, but looking from here, Boolean literal, let's save, test. Yeah, you can see it says that false is actually the fragment inside Boolean literal, but it's showing red. Unless we utilize them directly. So yeah, doesn't matter. So let's use them directly then. True or false. Then it's not complaining. Then we don't need this. Right? Okay. So up until now, we have our literals. We able to identify which one is the literal. Now let's prepare a constant. Constant is either a string literal, let's copy like this, or integer literal, or float literal, or Boolean literal. So let's try our constant. Our constant test rule. Okay. False. Constant Boolean literal. I hope you can see this. No? Can? Oh. There you go. Yeah, a constant. False is a constant. A constant of Boolean of a Boolean literal, and then of a false. And then we can try something like this. Yeah, it's a constant of string literal, and inside the string literal is the string. So how about this? It's a float. How about this? Well, it's a string. So using ANTLR able to identify identify sequence of strings and then conclude or infer the type of pattern used within that string. It's very convenient for us if we want to create our own language. We just specify the pattern, and ANTLR will try to identify what is actually the pattern, and then from that pattern we can gain the value. Yeah, this is a pattern of string. The value is something like that. This is a pattern of number, integer literal. This is a pattern of Boolean. Sorry, something like that. Okay, and then what we're going to do? We must be able to, let's see our construct here. We must be able to, then this become easy, become trivial, right? When we see a number 2, then we can easily say that, yeah, there is an integer literal. So just parse the content, which is 2, then we can infer it as a 2, as an integer. Yeah, this is a string, this is a string, this is a string. Oh, this is an expression. Okay. Or a function. Oh, this is actually a function. Okay, let's create a function. What is actually a function? A function would have a name, right? A name of a function could be, is actually a string literal, right? So let's define that. Function, okay, function is a string, a sequence of string. You can see this. This is a function. This is a function, for example. Let's put as function. This is a function. Started with, followed with an open and close brace. Okay, this is a function. The function can contain arguments. Okay, the argument could be a string, could be a Boolean, could be another function, or could be another expression. For example, function something like that. So what we can do is we need to identify this function, which is containing a function argument, and a function argument could be anything, right? So let's do this. A sequence of string. Okay, so a function should have a function name, which is the function name is a sequence of string, right? Could be A to Z or A to Z, all in uppercase, followed with another A to Z uppercase, and numbers 0 to 9. And this is could be multiple. So it should be a function name, right? So our function should start with a function name, okay, and then followed with a brace characters. Let's define the fragment for brace characters. So let's copy like that. Brace open. Let's call it bopen, and brace close. Okay. Let's make it nice. Oops. Oops. Okay. Brace open is these characters. Brace close is that characters. Okay. So it's a string literal followed by a brace open, and then with an argument list followed by an argument list, and then close with b closed. We have a function name. Okay, argument list is not there, so let's define an argument list. Argument list is a list of argument, which is an expression. So argument list should be an expression followed, could be multiple expression, followed by expression with a comma. Let's put something like that. Okay, the argument list can be existing or not existing, non-existing. So put it wrong. Something like that. Okay, what is expression? Okay, expression. Okay, what is an expression? Expression could be what? A constant, right? An expression could be a function. And then an expression could be what else? Expression, operator, expression. Right, it's a good idea, right? So expression, operator, then expression. Yeah, I like it. So what is an operator? An operator is any character, any mathematical characters. Yeah, all of these: plus, minus, division, multiplication, and mod. And a logical AND. How? Character AND, where is it? Where is it? Which one is it? Okay, that. Logical OR. Okay. What else? Equals, not equals, lesser than or equals, lesser than, greater than or equal. What else? I think that's it. This is what we call with EQ. This is what we call with not equal. Yeah. We call this less than or equal. We call this less than. We call this greater than. Ouch. And we call this greater than or equals. Okay. Yeah, we need to enclose this. Yeah. Okay. How can we easily do this? Just like that. Make it nice. Okay. There you go. And then let's put all of this as an operator. Let's copy this. What is an operator? Operator is all of this, right? Let's remove all of this. Oosh. Yeah, let's put all the pipes. That's all the operator. Okay. So okay. So a function should be a function name. Do we already do that? Yeah, function name followed with open and close. Brace close. And with between the open and close, we put an argument list. What I do? Oh my god. Sorry. Yeah, argument list. So argument list is an expression followed by another expression. But the argument list is optional. Okay, so let's try this. Let's talk about expression. Let's put this topmost because it's the most generic thing. Okay, let's try expression. Test expression. Issue with parser. Oh, okay. So okay. Sorry. Oh yeah, sorry, my mistake. We need to terminate that one. Okay. Expression should be a constant. For example, okay, expression. This expression is a constant. It's a string literal which is containing ASE blah blah blah. So if we put like that, it can easily identify that it is an integer literal, this expression. But if we put something like this, then it knows that it is a function. Voila. Right? So function name ASD f, and then there is a open, and then there is a close. How about if we put something here? Oh, error. This is not a valid function. So a valid function could have an argument of maybe a constant. Yeah, expression constant, but it failed to detect the closing. Why? Why? Because obviously we have put extra in our argument list. Where is our argument list? Argument list is an expression, comma, expression. Argument list. Okay. Where this comes from? Argument list. The argument list detect a closing. Yeah. Argument list. Okay, let's try it. Let's remove the argument list with this. Is this proper? No, because it's expecting an argument list. If the argument list is empty, let's put something like this. Is it valid? Yeah, it's valid. So if we put some number, dang it, it will still look for constant. This expression still look for constant. Yeah, it found the constant, but after the constant, the argument list expect nothing more. Ayo. Let me look into my cheat sheet. Oh, yeah. This is my mistake. If you found an argument list, it expects to be more than one argument, because this is a greedy mark, so we need to put like that. It could be one, or it could be many, right? It could be one, or it could be many. If it's many, it should divide it with a comma. So it could be like this first argument, the second argument, the third argument, something like that. So you can see that the expression is containing a function, which the function name is AS, and then the argument list is first expression, second expression, third expression. So the first expression is an integer literal, second is integer literal, also the third is a string literal. So there you go, our expression. But if we put a space, is it a valid expression? Then no, it is not a valid expression, because the space here is not expected. So we need to throw away any spaces. We need to throw away any spaces, because the parser will take account white space characters, spaces, tabs, carriage return. So we need to throw away all of this. How are we going to do it? We can do that is we simply put an ignore token in our grammar, like that. Then all spaces will be ignored, even though if we put tab, we put we put any space in between, no problem. It can identify all of that. So this is how you can identify space. A space is a space, a tab, what is it called, a new line, and this is a carriage return. It is skipped. So ANTLR will disregard if such character appears within the string that we want to parse. Okay. Okay. What else? Oh yeah, if we have a function like this, function, and then within the function we have literal, integer, what we call a floating point, a boolean, what else? Hey, why is this wrong? Why is it wrong? A function? This is not a function. True is not a function. It's a constant. Oh, because this could be identified as a function name. So our constants should be parsed first. We can solve this. Means that our definition should be taken into account first. Right? Wrong? No. All function names should be taken into account last. Yeah. So when you see a sequence of string without it is not a string literal or any other literal, and then you see a sequence of string, this sequence of string should be taken into account as a function name first. Yeah, this is how you have a higher. The true or false have a higher authority over the function name. But even though, we can still put function name inside. Like that. Or we can put, see? We can put something like 1, 2, 3 plus something like that. Or yeah, this is an expression. You can see that, yeah, there is the first expression, which is an integer literal, and then followed with a plus, and then followed with another literal, integer literal. We can put something like that, or we can put something like this. It's depend on us, right? We can make this valid. What is the return value? Should it return, like, I'm not a good mathematician. Should we return this as 2, or should we return this as 1, 1, string 1, 1? It is up to us. But logically, when we concatenate something with string, it will turn everything into string. It is illogical if we want to concatenate something with string and then we get the actual type. Okay. What else we should do? Yeah, we have this function. Okay, it could be, the argument could be an expression, right? Or could be something even more crazy, another subfunction, and then it has a concatenation. Wow. You can see. Great. So much heavy lifting is done by ANTLR. So how is this enough? Yeah, still valid. So you get the idea, right? What we're going to do, we're going to implement this. We're going to pull this information. We're going to parse, we're going to process. There should be a string called bearer, and then there is a function. The function takes 2 arguments. This function will look into the context and then fetch the value inside the context using this string. And it as the name implies, it should parse the JSON and then walk inside the JSON looking for the data access token. So yeah, this is what we're going to do. Later we're going to implement how the JSON path should work. Okay. Yeah. So what we're going to do next? I think this should be sufficient for our DSL for now. So this is how we're going to do, how we're going to approach this. Okay. Luckily, I don't know if you need to verify whether ANTLR plugin for Visual Code, VS Code, is actually there, and is it really as helpful as this plugin for Golang? So with this, we can easily generate a parser that we can utilize. So our program can easily do this, what the IDE do. The IDE can parse this string and identify which one is the expression, which one is the string literal, follow with what operator, and then follow with what. So we can see that this is a literal string, this is a literal of function, and then there is an operator in between. You can see that this is a string literal, a plus operator, and then the function. Inside the function, you have a function name, which is the function. This is the function name, right? Yes, this is the function. And then we can see that there is a open brace, close brace, there is an argument list, and then there is an expression within the arguments, the first expression, the second expression, and so on and so forth. The first expression in the argument have all of that. So what we're going to do, we can create this parser from ANTLR. ANTLR will do all the generation of code for us to use, so we can parse. So let's configure. This is how the plugin in Golang, the ANTLR plugin in Golang works. So let's configure. Okay, the output directory will do where all output is generated. We put ANTLR. Okay, ANTLR, yeah, ANTLR. So within this directory, the generator will create a directory called ANTLR4. Okay, the imported grammar is in the same directory. Grammar file is the what we call is Symon-Lang. Symon-Lang. Okay. Oh, encoding, encoding. Let this fill. Package namespace. Okay, the package is Symon-Lang. Symon-Lang. Okay, the language is Go. Case information in the previous, leave it as it is, generate parse tree, listener, and visitor. We only need listener. I don't know how to use the visitor part, but I only need listener. So yeah, let's do that. So okay, let's generate. Right click, generate ANTLRs. Okay, so there you go. There will be a directory called ANTLR. Inside the ANTLR will be a package called Symon-Lang. There you go. So this Go code is all we need to be able to parse the string. Okay, for every parsing activity that it done, it will call a listener. This is the listener. Fortunately, the listener is not that far, not that much. So what we're going to do from this Symon-Lang listener, I don't like this. This interface using a smaller letter, but because I don't like it. Let's remove this first. Let's recreate. Delete. Okay. Let's configure. I wanted Symon-Lang in capital letter. Yeah, okay. Generate. Okay. Symon-Lang listener. I think they don't care. They expect us to actually implement this thing. So let's implement. Okay. Now what we're going to do? We're going to implement this. You can see the naming, the function naming of ANTLR. There is enter expression, enter function, enter constant, enter operator. Let's compare this with the grammar. So enter expression, enter function, enter constant, enter operator, enter argument list, enter literal string. So it will have that. Okay, and also the exit expression, exit function, exit constant, exit operator, and all of them. They all goes in pairs. Exit expression, exit function. So what ANTLR do? Maybe you already figured this out yourself. So as we parse the string, ANTLR will call these functions as they parse through the string. Let's try this expression, test rule. So when you can see here, ANTLR will call enter expression first, and then it will call enter expression again, and then it will call enter constant, enter string literal. After the string literal has been called, it will call exit string literal, exit constant, exit expression, and then enter operator, and then exit operator, and then enter expression, enter function, and then go to what we call enter argument list, enter expression. It will pass through. So while while the listener function getting called by ANTLR, we need to construct what we call an AST, abstract syntax tree. So this is a tree, right? We need to construct the abstract syntax tree according to this layout. Okay, how are we going to do that? Very easy. First, let's create our abstract syntax tree. Let's call it, let's create a directory. AST. Let's call that. Okay. Okay, we have expression. Let's create all of this node, all of these trees. Okay. Let's create that. New file, expression. Okay, we have a class what we call as an expression. Type expression, a structure. Okay, let's repeat. What is next? Constant. Let's create a constant. What else? Function. Okay, so we have this. Yeah, I'm a lazy person. Okay. What else? Yeah, we need operator, argument list, constant, string literal, integer literal, float literal, boolean literal, operator, argument. Yeah, all of them. We need to create all of them. So bear with me, okay? Function. We already have function, constant, expression, operator. What else? String literal, integer literal, float literal, boolean. Float literal. Boolean literal. What else? What else? What else? Boolean, float, integer, string, operator. We already have operator. And then argument list. Do we have argument list? Not yet. Okay, create. New Go file. Okay, argument list. What else? Expression, we already have expression. Yeah, that's all. Now, let's see what happens if we need to construct the expression node. You can see that this expression node have function. It have a child expression for the left and right of the operator. So we'll have also the operator, right? So expression should have constant. You can see expression, okay, should have constant. Okay. And what? Function. What is our expression? Expression, function, and also a child expression, the left side expression. Left expression is an expression, and the right expression. Okay. So all of this, yeah, obviously this is a pointer. Okay. What next? Yeah, operator. Okay, we need an operator. Yeah, because we don't have operator. Type. Okay, we have that. Let's see the others. Okay. Operator. Okay. Integer literal. Float literal. Boolean literal. Argument list. Argument list, not literal. Okay, okay. So argument list. Let's look into our grammar. Argument list. Okay, argument list could have multiple expression. First expression, second expression, so on and so forth. So let's create that. Let's create it. Argument list. Okay, argument lists have arguments, which is an array of expression. Right, so continue. Boolean literal have a Boolean value. Very easy. Value is a Boolean. Boolean string, the value is a string. Operator, later, integer, value is an integer. I put a 64-bit variant because we always work with integer 64. Even with reflection, 64-bit is always reference in Golang. So let's use integer 64. Function will contain the function name. The name is the string and the argument list. An argument list, yeah. You can see here, right? From here, a function have a function name. This is very important because we need to know what is the function that we're going to call, and an argument list. So function have name and argument list. What else? Argument have multiple expression. A Boolean has that. Constant would contain a Boolean as in Boolean literal, yeah. A string as in string literal. It have a integer as in integer literal and a floating point as in the float literal. This is all the literal that we have, right? check. Let's check. Yeah, string, integer, float, and boolean. Where is our constant? There you go. And then operator. Let's see here. Could be all of this. This is all strings. Plus is a string of plus. Minus is a string of minus. So all of this is string. So we just need to know the operator. We need to record the operator string. So operator is a string. Okay. So are we set? Oh, float literal. The value is a float 64. Okay. Excellent. What we're going to do next is to construct these nodes of object according to how ANTLR call us. You can see we need to construct something like this. Okay, there's an object of expression, the left expression plus the operator, and the second expression. The first expression would contain a constant. Constant will contain a string literal. All is like that. Okay. So how we can do this? How we're going to do that is by to implement our own listener. Let's create our own listener. Symon-Agent listener. Okay. Is a structure, a type, Symon-Agent listener. Okay. It's a structure, and this structure inherits all of the Symon-Lang listener, this listener. Okay. Oh, sorry, base listener. Base listener. Okay. And then for all of this base listener, we should import this. Where is the base listener? This one. Symon with capital L. Why can't we reference that? It's a Symon-Lang. Okay. This listener should be that. Yeah, there you go. And then we implement all of those in the base listener. All of those. Yeah, except this visit error, because later we're going to implement that because we need to do error handling. But we can do that later. Okay. Okay, let's replace all of this with our listener. Base Symon-Lang listener. We replace it with Symon-Agent listener. What? Something is wrong? Symon-Agent. Oh my god. Replace all. Okay. And then we need to import ANTLR. Oh, we have an import ANTLR. Yeah, we need to import ANTLR. Sorry. How are we going to import ANTLR? There you go. Terminal. Go get ANTLR. Guys, if you have any question, just type in whatever you need to know about on the chat. Ask me anything about ANTLR, about Golang, about anything. If you have anything in question, just ask away. Okay. I will continue doing this for maybe another 10 minutes because I'm going to cut this within 10 minutes and we're going to continue again the second part of learning ANTLR and implementing our own DSL into our application in 10 minutes. Let me finish this first and then let's dry run our parser. Okay. Yeah, we need to implement this. Okay. Okay, it's done. ANTLR is actually so import. Let's do this. Whoosh. Like that. Let's import ANTLR. No worries, this error will eventually disappear because it needs to the ID will reindex soon. So yeah, we need to change all of this pointer into Symon-Lang. Yeah. Okay, let's try to build this. This version 1% is not compatible with the version of Windows that you are using. This computer system information has contact this. What? Module github.com ANTLR4 latest found, but does not contain package GitHub ANTLR4. What is wrong with this? Uh, I don't know what happened. Module github.com ANTLR4 latest is found, but does not contain package ANTLR4. What is wrong, guys? Any advice? I will let me sort this out offline. Anyhow, we already been talking, like the session is already more than 1.5 hours. So I will keep this around 1.5 hours, 1 hour for 40 minutes. So I think we make the cut here. Thank you all very much. I will sort this out. So our session tomorrow at 2 o'clock, I'll make sure that this problem is solved. We can continue. But basically, what I'm trying to do here is that we are implementing the base. So actually, I just show you a Symon-Lang listener. This is actually an interface. Yeah, the interface is on the lowercase because this should be internal to our application. And all of this interface need to be implemented by our listener. So basically, they create this listener. They have a default implementation of the listener. They call it base listener. We just create our own listener, and then we override all the method from this listener. This is what I'm doing here. So this listener, we're going to tell ANTLR, while you parsing the text, you call this function that we defined. Okay, this function will create all the node as we define inside the AST here. So we create all of this node, and then later on we execute this node. So for example, when we call execute this node, the function node, it will look for our implementation of this function name with this argument and just execute that function, right? I will show you in more detail on how we're going to do this tomorrow. So please make sure join me again tomorrow. I'm trying to be as consistent as possible. Sorry for today late. Every 2 o'clock, every day, every weekday, maybe Saturday, maybe Sunday also, I'll try to force myself to do this. So at the end, we're going to have a working software, a working application, and you follow me how do I approach things in programmable programming context, sometimes in solution. I hope I can give you tips here and there, and maybe I can also learn from you guys. Okay, thank you very much. We'll continue again tomorrow, 2 o'clock. See ya.